A velocity time graph is different from a speed time graph. The main reason being that the velocity of an object is a vector quantity. It's got size, magnitude, and direction. So how are we going to actually display that on a graph? The velocity time graph showing the velocity of an object over a given time must also be capable of showing its direction. So how's that achieved? Well, in this case, we're going to be throwing a ball into the air. The ball is going to go up and it's going to come down. That's our everyday experience. But on a velocity time graph, we have to label the velocities in the following way. When the ball is moving upwards, we give the velocity a positive value. When the ball is moving downwards, we give it a negative value. So any negative values on that graph will indicate to us not just the size of the velocity, but also the direction. It will mean the ball is going downwards. Any values on that graph which have got a positive velocity tells us that the ball is moving upwards. That's how simple it is. Let's see how we can produce the graph of a ball moving up and then falling down. There's the graph. The ball is moved up and the ball is fallen down. Now you can see at 1 second the velocity of the ball is 0, and that's because at 1 second the ball is momentarily not moving. Its velocity is going to be 0. At 1 second we can see the velocity of the ball is going to be 0. But after 1 second the ball is moving downwards and therefore its velocity will have a negative value. As I said before, any velocities that are positive means the ball is moving upwards. Any velocities that are negative means the ball is moving downwards. So we can now interpret the velocity time graph of this ball being thrown into the air. At 0 seconds, the ball is thrown upwards with a velocity of 10 meters per second. At 0.5 seconds, it's going to be going up again with a velocity of 5 meters per second. And we can see from that top part of the graph from 0 to 1 second that the velocity is going to be reduced, is going to be decelerating on the way up. At 1 second, the velocity of the ball is going to be equal to 0. It's momentarily stationary. After 1 second, the velocity of the ball is going to become negative, which means the ball is coming downwards, and its velocity is going to be increasing in the negative direction, which means the ball is accelerating downwards. Now there's something for you, because we know that gravity, the force of gravity, accelerates objects downwards. Now we can visually see this by drawing in the velocity vectors of the ball at different times. Remember our technique to visualize what's happening with the graph? We draw our velocity vector with the tail on the time axis and the nose right up to the graph, and you can see that when we draw in all the successive vectors, we see that the length of them is being reduced, which means the velocity's magnitude is being reduced, which means it's decelerating. And it's decelerating because gravity is pulling it in the opposite direction. It's decelerating it. At 1 second, we have the velocity of the ball equal to 0. And after 1 second, you can see to draw the vectors, keeping the same rule, the tail of the vector must be on the time axis, the nose onto the top of the graph. You can see that the length of the velocity vector is getting bigger in the negative direction, which means the velocity is increasing on the way down. In this example of a velocity time graph, a car is moving along a horizontal road. Now, positive velocities means that the car is moving to the right. Negative velocities means that the car is moving to the left. So the velocity time graph will enable us to find the magnitude and the direction of the car's velocity. Velocities to the right will be positive. Velocities to the left will be negative. Okay, let's set the car in motion along the horizontal road and chart the velocity time graph and then explain what's happening. Set the car away. And you can see it's moving towards the right. It stops, and then it reverses back the way. So you can see the top part of the graph is displaying the positive velocities, which means the car is moving to the right, and the bottom part of the graph from 7 seconds onwards have all got negative velocities, which means that the car is moving to the left. And that little spell between 6 and 7 seconds, there was no velocity, and that's the time when the car was at rest. So to recap again, between 0 and 2 seconds, we are accelerating to the right. The graph is sloping upwards. In the next part, from 2 to 4 seconds, you can see that we're going to have a constant velocity, but we're still moving to the right because the velocities are still positive. From 4 to 6 seconds is decelerating, its velocity is decreasing, but it's still moving towards the right. And then you get that spell between 6 and 7 seconds where the car had stopped, it's got no velocity. Between 7 and 8 seconds the car is moving to the left this time because the velocities are going to be negative. And what's more, the velocity is increasing, so therefore it's accelerating but to the left. Between 8 and 9 seconds the car has a constant velocity, but it's moving to the left. And the final part of the journey, from 9 to 10 seconds, the car is going to reduce its velocity, but it's still travelling to the left. And we can pick that up from a simple fact that if the velocities are positive, it's moving to the right, and if velocities are negative, it's moving to the left.